Good afternoon, everyone. Welcome to Cloud9's Wednesday webinar series. Cloud9 Infosystems is a boutique technology consulting firm, and we are focused on growing enterprises. We are a Microsoft Gold partner in cloud platform, data analytics, and application development. Cloud9, we recently launched the Wednesday webinar series that takes place the alternate Wednesdays. But going forward, we will be having webinars every Wednesday from 1 to 1:30 p.m. the Central Time. Um, this week's topic is Go Serverless with Azure Functions, which is a part of Serverless Computing series. A speaker for this series is Aniket Wani. And before we start with the webinar, I just want to announce about our upcoming roadshow event on December 14th at the Microsoft office in Chicago. So all of you are most welcome. And the topic for this roadshow is about Power BI. So please do join us for this event. Now Aniket will take over. Thank you.
Thank you, Nicola. Welcome all. I'm Aniket Wani from Cloud9 Infosystems, and today I'm going to discuss about serverless computing with Azure Functions. To all my developer friends out there, what if I told you that you can spend all of your time building and deploying great applications and none of your time managing servers? Yeah, you heard me right. Serverless computing lets you do just that because the infrastructure you need to run and scale your applications is managed for you so that you can focus all your efforts on your business. You can redirect your resources from infrastructure management into innovating and bringing applications to the market faster. This is the agenda, so just a few things that we will be talking about today. The first thing first, we will start off by understanding what we mean by serverless computing. We will then move on to the main topic of the day, Azure Functions, and how does it fulfill all the criteria for being serverless. We would then delve into programming model of Azure Functions and some other technical terms related to it. Then we would conclude with some of the best practices for using Azure Functions. Let's start. So what is serverless computing? It is the abstraction of servers, infrastructure, and operating systems. When you build serverless applications, you don't need to provision and manage any servers, so you can take your mind off infrastructure concerns. Serverless computing is driven by the reaction to events and triggers happening in near real time. As a fully managed service, server management and capacity planning are invisible to the developer, and billing is based just on resources consumed or the actual time your code is running. So what does all this mean? Serverless computing allows you to focus on your application and not the infrastructure. You can spare your teams the burden of managing servers. By utilizing fully managed services, you can focus on your business logic and avoid any administrative tasks. With serverless architecture, you simply deploy your code and it runs with high availability. You can gain flexible scaling. Serverless computing scales from nothing to handle tens of thousands of concurrent functions almost instantly, to match any workload and without requiring any scale configurations. It reacts to events and triggers in real time. The main thing is we only pay for resources that we use. With serverless architecture, you only pay for the time your code is running. Serverless computing is event driven, and resources are allocated as soon as they are triggered by an event. So you're only charged for the time and resources it takes to execute your code through sub-second billing or micro billing. So now we delve into our main topic for the day, Azure Functions. Azure Functions is a serverless compute service that enables you to run code on demand without having to explicitly provision or manage any infrastructure. Use Azure Functions to run a script or a piece of code in response to a variety of events. Microsoft is promoting this new service as a serverless option for simple APIs, triggers, notification, and anything that you can think of that can be processed by a function, regardless of the programming language you use. It's worth mentioning here that just like any other cloud service or feature, Azure Functions isn't the solution for everything. However, Azure Functions are helpful in supporting your application without the need to provision of new fully featured API or servers, etc. etc. Seamless DevOps experience with Azure Functions. As with all code that eventually ends up in production, it's important that there is a proper DevOps story. Continuous integration and continuous deployment is integral and vital even in the new world of serverless architecture. Azure Functions can run online using the Azure portal, or you get to choose between Visual Studios on Windows and the VS Code on Mac or Linux machines with Azure Functions CLI installed. They both allow you to write, debug, and test your functions locally without the need to touch the browser. Developers using Azure Functions can implement events in a variety of languages like JavaScript, C Sharp, Python, PHP, Java, as well as some scripting options like Bash, Batch, and PowerShell. Also, developers can upload and trigger pre-compiled executables for the Azure Functions to run. Each Azure function is provisioned with a Git endpoint, allowing for seamless local development and continuous integration using services like Visual Studio Team Services, GitHub, and Bitbucket. Developers can monitor and troubleshoot Azure functions with logging capabilities included in the Azure Functions experience on Azure. Let's talk about triggers and bindings. These are two technical terms related to Azure Functions. Triggers and bindings are nothing but a declarative way to define how a function is invoked and what data it works with. A trigger defines how a function is invoked. A function must exactly have one trigger. Triggers have associated data with it, which is usually the payload that trigger the function. These are a few examples of triggers. We can have a scheduled time can be a trigger for another function to run. Like your Azure function can run every second or every minute. An HTTP request can trigger your Azure function. Any changes in your Azure storage services like your blob storage, your queues can also act as triggers for your Azure function. Binding, on the other hand, are of two types, input and output. Input and output bindings provide a declarative way to connect to the data from within your code. Like triggers, you specify connection strings and other properties in your function configuration. Bindings are optional and a function can have multiple input and output bindings. Let's check out the programming model of Azure Functions. Using triggers and bindings, you can write code that is more generic and does not hard code the details of the services with which the function interacts. Data coming from services simply becomes the input value of the function. To output the data to another service, say such as creating a new row in Azure Table Storage, we can use the return value of the method. Or if you need to output multiple values, we can use a helper object. Use binding in your code. Triggers and bindings have something called as a name property. This is an identifier you use in your code to access that particular binding. You can configure triggers and bindings in an integrate tab in the Azure Functions portal, which I will show you soon. But under the covers, the UI actually modifies a file called function.json in the functions directory. We can edit this file in the advanced editor on the portal, which we will see soon. Coming to some applications, things that Azure Functions can do. Timer-based processing. So Azure Functions supports an event based on a timer using the cron job syntax. For example, say I want to execute a code that runs every 15 minutes and cleans up a database table based on some custom business logic over here. Another example or an application that we can implement is that Azure Functions supports triggering an event based on some event happening in some other Azure service. Like for example, let's execute a serverless code that reads newly discovered test log files in an Azure Blob Storage container and transforms this into an Azure SQL database, which can later be used by Power BI to provide analytics. And there are many more applications that we can think of. But now let me show you guys a quick demo for using the Azure portal. This is my Microsoft Azure dashboard. To create a new Azure function, we can click on new, and under compute, we have the functions app. You can go ahead and create a functions app based on your requirements and then either pin it to your dashboard the way I have done, or you can find it under the functions app tab on the left hand side. So for this demo, I have already created an app and I'll just show you. This is the page where you can go ahead and edit the settings of your functions. But for now, I'm going to leave everything to the default functions that Azure provides when you create it. You see this app is running on the central US location under a particular resource group and has a particular URL as well. So you can go ahead and add functions. We add a function, you get an option, there are many options that we get here. We even have some quick start templates that we can start off with. So you can either have a webhook or an API based function. We can have a timer based function using various different languages like C#, Java, JavaScript, etc. I'm already having a function here that I've created just for this demo. This is my code, but before getting into that, let me show you the integrate tab that I was talking about before, where you can go and add triggers, input bindings, and some output bindings. I'm going to show you the advanced editor, which has the function.json file like I mentioned before. So in this demo that I'm having, we just have one HTTP input, which is going to be a trigger, and an HTTP output that is going to give that we are going to use as our output binding. Like you see, both these things have a name property with which we are going to access these functions and these bindings and triggers in our main code. So let's just check our code out. This is a very simple code that I've written here. I'm having an HTTP request message which is coming in. I've put some business logic to parse that request message that comes in and take out and put it in a string variable called name. If my response is okay, if the status is 200 and it's okay, I'm gonna reply back saying hello and the name that I provided. So this is one more thing that I want to show you guys here is that Azure provides a very beautiful testing tool over here in the portal, so that I don't have to go and use Postman or curl or anything like that. So through this test portal, I'm just gonna have a get request. I'm gonna add a parameter saying name and value saying Aniket. Now when I run this, I should get a reply saying hello Aniket, right? So let's go ahead and try it. There you go. It says status is 200, okay, and I get hello Aniket as the output. One more way of running the same application is you can get the function's URL from here. Just gonna copy it, go to new tab, paste the URL. I'm just gonna add a normal name parameter to it, saying, I don't know, Aniket again, or say, and press enter. Oops, I made a mistake, I guess. Sorry about that. Oh, my bad. I had disabled the function. My bad, sorry. There you go. Yeah, Maniket Vani. So this is actually a good feature that happened. It's a good thing. So once you're done using the function, you can enable and disable it so that you're not charged when you're not using the function, right? So that's pretty much it for the demo. Let's get back to our presentation here. Like we saw, and we have many applications that we can implement. Anything that we can think of, I'm pretty sure we can implement it using a serverless architecture. So having shown you the applications, having shown you what serverless computing means, having shown you what Azure Functions can do, let's see some of the best practices that Azure Functions we should follow in order to have a good Azure function. So the first thing first, functions should do only one thing, like the demo that we saw. All that my Azure function did was take an HTTP request, process it, and give an HTTP output. That's all that my Azure function did. So it should do only one thing. Azure function should finish as quickly as possible. So it should take in the input, do some processing, give the output ASAP. It should be stateless. That is, it treats each request as an independent transaction and that is unrelated to any previous requests. Functions should be idempotent, which means that clients can keep on making the same call repeatedly and the function should produce the same result every time. When do we use this function? That's the question that comes to our mind, right? When do I use this function? But this is what I think are probably the best scenarios when Azure Functions should really shine out. Number one, if your application is stateless, like I mentioned before. Number two, whatever your logic your function is implementing, if you need that to be scalable. Like for example, if I know that I'm going to get a lot of HTTP requests, then I would like to scale my function to handle those many requests. So if the application needs scalability, Azure Function is an answer to it. Number three, and this is in continuation with the same point, the previous point, that Azure Functions will be a good option if you expect that your workload is going to be sporadic. And four, when you have lots of different services involved, which you need to be glued together, like the example that we saw up there, where we wanted to run a function whenever a new log file is added to a blob storage to process that log file and then enter it into a SQL server. So here I'm having the blob storage and the SQL server, which we are trying to glue together. So these are some places where Azure Functions really come out and would be useful. As that's what I think. And so yeah, go ahead and use Azure Functions. And if you have any doubts, we are always here to help. Get back to us. You can send us emails. You can, if you want this presentation deck as well, do get in touch with us at cloud9infosystems.com, and we will get back to you soon.
Thanks, Aniket. And if you have